More trig graphs. We've been studying the graphs of sine and cosine, but the other four trig functions also have graphs. So we're just going to learn the parent graphs of these other trig functions. We'll not be stretching, shrinking, or moving them. The scale for all of these graphs then will be the parent graph scale, pi over 2, pi, 3 pi over 2, and 2 pi. First, let's do y equals cosecant x. As you remember, cosecant is the sine flipped over. So to draw the graph for cosecant, we'll first draw the parent graph of sine, but we're going to draw it dotted. And so sine graphs, remember, start at 0, 0, and when you go to the right, they go up, cross, down, and back. But I'm going to make it dotted because this is going to serve as a guide for our cosecant graph. And down, cross, up, and cross. Now, since cosecant is the sine flipped over, everywhere the sine is 0, which is where it crosses the x-axis, when I look at the cosine there, if I flip over 0, I have 1 over 0, which is undefined. You can't divide by 0. So every time sine crosses the x-axis, cosecant is undefined. And we'll show that by drawing vertical asymptotes at every point the sine crosses the x-axis. And again, these are just going to serve as guides for the actual graph, which I'll do now. Flip over all the hills and valleys within the boundaries of the vertical asymptotes. And there's the cosecant graph. The secant graph is set up just the same way, except secant is based on cosine. So we'll start with a cosine graph, but dotted. Cosine starts, remember, up at the highest point. And just like the sine, wherever the cosine crosses the x-axis, the secant is undefined, because that would be a flipped over 0, which can't be done. So vertical asymptotes everywhere the cosine crosses the x-axis. Flip over all your hills and valleys. And there's the secant graph. Tangent. You may recall on the unit circle that the tangent is undefined at the very top and at the very bottom of the unit circle. It's undefined then at pi over 2. So if it's undefined, we put a vertical asymptote. It's also undefined at 3 pi over 2. And so it would be undefined at the negatives of those angles too. And the tangent is equal to 0, at pi, and at 2 pi. And then on the other side, it would be at negative pi and negative 2 pi. So that's where it crosses the x-axis, and then the way you finish out the graph for tangent is you have a smile on the right side, frown on the left side, staying within the boundaries of the asymptotes. Oops. So there's the tangent graph. The cotangent graph is going to be everything that we've drawn here completely reversed. So for cotangent, my asymptotes are at 0, at pi, and at 2 pi. And then everywhere we had asymptotes for tangent, the cotangent will cross the x-axis. Tangent was smile on the right, frown on the left. Cotangent is the flip of that. Smile on the left, frown on the right.